Yo GCSE, in a previous video, I proved to you or showed you how these first 5 rules operate. If you haven't seen it yet, then I recommend you go back to that video and check it out. But as a quick recap, the first rule is if you take 2 numbers with the same base, you add the powers. So remember, this is the base number, this is the power or exponent or the index. So as long as these 2 values are the same, these rules apply. Now the second one, if you divide 2 numbers with the same base, you subtract the powers. If you take a number, raise to a power, raise it to another power, we multiply the powers because this is an application of rule 1. Rule 4, anything to the power of 0 is 1, provided the base number is not 0. Rule 5, power negative 1 means reciprocal. Remember J. Cole, flipping like reciprocals. So reciprocals just swaps the numerator and denominator. X is x over 1, so when we flip it, it becomes 1 over x. It does not multiply it by minus 1. In this video, I'm going to show you guys how these last 3 rules work. Okay, so rule 6 is saying if you have a fraction raised to a power, then you just distribute that power to the numerator and the denominator. It's pretty self-explanatory. If we look at an example, it's kind of like an application of both of these, I guess, except rule 2, we don't have powers on them, although we could apply it. So if I have, I don't know, even just x over y, and I have cubed, I am saying you're distributing that 3 to the top and the bottom. Why is that? Well, cube just means repeated multiplication, right? So you're taking x over y, and you're multiplying it by itself 3 times. Then essentially, all of this, you're just multiplying the top and the bottom. You have x times x times x divided by y, which is x cubed over y cubed. Okay. What's interesting as well is what happens if I have a power here. Okay, let's take a look at that. It's basically the same thing. It's just then we are applying rule 3 as well. Okay. How do we apply that with rule 3? Let's change this. What happens if I change, instead of x and y, I have x squared and y squared? An easy way to think of this is just imagine I cover this up. That says x squared all cubed. That's just rule 3, isn't it? So that's all you're doing. You're doing 2 times 3. And same thing with the denominator. Imagine that wasn't there. You have y squared raised to the power of 3. It's just operating in the denominator. So again, you have 2 times 3, which is x to the power of 6 divided by y to the power of 6. Okay, so it's pretty simple. You're just distributing that power to the numerator and the denominator. What about rule 7 then? This is a very interesting one. So we were kind of discussing this in the last video where we had 27 to the power of a third. And I showed it to you guys in 2 different ways. Okay, now how did I show it to you? And I'm going to prove this to you in 2 different ways as well, explain it in 2 different ways. So we looked at 27 to the power of a third. And what I did was I rewrote 27 as 3 cubed raised to the power of a third. Well, using rule 3, a number raised to a power raised to another power, we multiply them, right? So these cancel. Yeah, a third of 3 is 1. Okay, so I'm saying to you guys that 27 to the power of a third is 3. Well, 3 cubed is 27, which means 27 cube rooted is 3. Well, that must mean then that power of a third means cube root, indicating that whatever's in the denominator tells you what root you're taking. So if that was a half, it would be the square root, which in this case would always be positive. The root function is always positive, which is one for another video. But you guys always need to know that, I haven't really written anything there, let's make it 9. Root of 9 is positive 3, not negative 3. This is the root function, which is always positive. Okay, now if that was 1/4, you'd be taking the 4th root. Now what's another way we could prove this situation? let's look at the root function. Now the root function, like we just looked at, the root of 9 is 3, right? You're saying what multiplies by itself to give you 9, and the answer was 3. So let's take a look at x to the power of a half. Okay. Now I want to figure out, when it comes to power half, we're thinking, like I said, what multiplies by itself to give you the number that's inside the half, isn't it? Okay, I want to figure out what multiplies by itself to give you x to the power of 1. Okay, x to the power of something times x to the power of something is power 1. When we multiply two numbers with the same base, we add the powers. Yeah, so we get x to the power of 2a is x to the power of 1. Okay, well, if these two base numbers are the same, it means 2a equals 1. 2 times the number is 1. That number is 1/2. Okay, well, what does that mean? It means that when you take x to the power of a half and you multiply it by itself, you just get x. And that's how the root function behaves. Okay? Another way you can even think of it is when you multiply a number by itself, you're squaring it. Yes, squaring is the inverse of half. Squaring is the inverse of rooting. Half cancels the 2. We're again left with x. Okay, so if I gave you guys an example, just to really reiterate that the denominator indicates what root you're taking, is if I had 9 to the power of a half, okay, and I square that, what should I be left with? Well, we're saying that power half means to root. The root of 9 is 3. Then when you square it, you get back to 9. Well, that must mean these are inverses of each other. They're the opposites. It works because a half of 2 cancels to give you 9. Okay? So this proves, not necessarily proves, but explains the rule that the denominator tells you what root you are taking. That's why we say the nth root of x. Okay? Now this takes us nicely to rule 8. What happens when we have something on the numerator? So far we've been looking at 1 over n and saying that the denominator tells you what root you're taking. What happens when we have something on the numerator though, like rule 8? It's all about how you rewrite it. Okay? So I have x to the power of m over n. I can rewrite like this. X to the power of 1 over n, then raised to the power of m. Why is that? Because when you take a number raised to a power, raised to another power, I multiply the powers. And if I do 1 over n times m, that's m over 1, right? Which 1 times m is m, n times 1 is n. So nothing has changed. This is rule 7. It's the nth root. So it's the nth root of x raised to the power of m. And that's the rule explained. So what does that mean then? It still means that the denominator tells you what root you're taking. Then this tells you what repeated power you're taking. Yeah, so repeated multiplication. Think of m for multiplication. Because if that was as 2, it means you're squaring it. You're multiplying by itself twice. Just for ease, I'm going to call it power because, you know, when we think of powers, we think of repeated multiplication rather than roots. But we're just taking a distinct difference between this being a root and this being the repeated multiplication aspect of the problem. Now, in general, it's advisable to take the root first. So say I gave you guys this question, 9 to the power of 3 over 2. Okay, remember this means what root you're taking, and this is telling you what power you're taking, right? You don't want to do 9 cubed first, because Who knows what 9 cubed is off the top of their head? I mean, some people in the comments probably will say, I know what it is, mate. But whatever that is, you wouldn't be rooting it after. So, root it first. The root of 9 is 3. Write it down. Cross that off. We're still left with the cube. Okay? And 3 cubed is 27. Okay? And that's how we do these problems. So that's rule 6, 7, and 8 shown. In the next video, I'm going to explain or show you a really interesting problem which is going to cover kind of all these rules in one. You don't want to miss it. So make sure you're subscribed and like the video if you want more content like this. And if you're interested in my full GCSE courses, then check the link in the description. I'll see you guys in the next video. Nice.